Hello, everyone. My name is Max Key, and I'm here to share some insights into Docker, which is a technology that is making a significant impact in the world of software development. This presentation is part of an assignment for my Software Engineering 2 class, and in it I will guide you through the intriguing journey of Docker, what it is, why it matters, some of its history, and how it has transformed the way we create and deploy software. So to begin, what is Docker? What is Docker exactly? Docker is an open source platform that streamlines the creation, deployment, and execution of applications within isolated, lightweight, and portable containers. These containers package everything an application needs to run, ensuring consistent performance across different environments. Think of it as a standardized shipping container for your software. Now, a little bit of history about Docker. Docker's story begins in 2013 when a company called .cloud decided to change its name and pivot its business. They refocused on their internal project named Docker, which they then open sourced, and it quickly gained immense popularity. Before Docker, the software development and deployment landscape was quite different. Traditional deployment methods involved setting up and configuring servers manually. Developers worked in silos, each with their unique environment, and deployment often led to "it works on my machine" problems. Challenges in consistency, resource efficiency, and scalability were common. Before Docker, developers and operations teams faced significant challenges. As mentioned previously, they had to deal with these complex server configurations, ensuring all dependencies were met, and managing differences between development, testing, and production environments. This manual setup was not only time-consuming, but prone to errors. The scale-up processes were slow, involving the provisioning of new servers, while the scale-down process was equally time-consuming. They need a more efficient, consistent, and scalable solution, and Docker stepped in to give a solution. So why choose Docker? The significance of Docker lies in its ability to solve these problems. 1. Consistency. Docker guarantees consistency across different environments, solving the "it works on my machine" problem. 2 is efficiency. Containers are incredibly lightweight, starting in seconds rather than minutes. They share the host OS kernel, making them much more resource efficient than traditional virtual machines. 3 would be isolation. Docker isolates applications and their dependencies within containers, reducing conflicts and creating a more stable deployment and development environment. And 4 is scalability. Docker is perfectly suited for microservices architectures, allowing you to scale services up and down quickly and efficiently. Next, we'll go over some of the components of Docker. One, the most important, is the Docker engine. The Docker engine is the heart of Docker. It's responsible for running and managing containers. 2 are the images themselves. Docker images. These are templates for containers. Images are created from Docker files, which define what goes into the container. And that brings us to the third, is Docker containers. Containers are the instances of Docker images. They run the application and its dependencies. And 4 is Docker registry. Docker registries, such as Docker Hub, is like a library of images where you can store, share, and distribute your Docker images. Next, we'll go over the workflow of Docker, kind of an overview of how Docker operates. The first step is to build an image. You define what goes into your container using a Docker file, and then build the image with the docker build command. 2, you next run the container. So to start a container from your image using the docker run command. Next, you can interact with these containers using the docker exec command to execute commands within the container, and the docker logs command to access the container's output. A couple of use cases. Some areas where you really see a lot of benefits from using Docker. One would be development and testing. Docker ensures the development environment mirrors the production environment, minimizing the "it works on my machine" issues. 2 is microservices. Docker's isolation makes it perfect for microservice architectures where each service is encapsulated in its own container. Next is for CI and CD pipelines. Docker is a linchpin in modern software development, allowing for consistent and automated testing and deployment. And 4 is legacy application support. Docker can now breathe new life into legacy applications by allowing them to run on modern infrastructure. Next, we'll talk a little bit about Docker's impact on the industry. Docker's emergence marked a turning point in software. It introduced a shift from monolithic application development to microservices, where applications are broken down into smaller, independent components. This change in perspective transformed how software was developed, deployed, and is maintained. Before Docker, large applications were cumbersome and challenging to manage. Developers struggled with maintaining a consistent environment across development, testing, and production phases. With Docker, these challenges were significantly mitigated. Docker also had a profound impact on DevOps practices. DevOps aims to bridge the gap between development and operations teams, and Docker's consistency and scalability made it the perfect tool for DevOps pipelines. Automation, continuous integration, and continuous deployment became more manageable and efficient. Since its inception, Docker has continued to evolve. Docker Inc., formerly known as .cloud, the company behind Docker, has expanded its ecosystem and introduced additional tools to enhance the Docker experience. Tools like Docker Compose for multiple container applications and Kubernetes for container orchestration have become integral parts of the Docker ecosystem. Docker's also had a huge influence on cloud computing. Docker's impact has extended into the world of cloud computing. Leading cloud providers such as AWS, Azure, and Google Cloud have embraced Docker and offer container orchestration services to make it even easier to deploy and manage containerized applications at scale. Docker's influence can also be seen in serverless computing. Serverless platforms like AWS Lambda and Azure Functions have adopted containerization to run code in isolated environments, providing a more consistent and efficient experience. As we look ahead, Docker continues to play a vital role in the ever-evolving technology landscape. Its flexibility, portability, and scalability make it well suited for emerging technologies like cutting-edge computing and the Internet of Things, where efficient deployment and management of applications in diverse environments are critical. In addition, Docker's commitment to security and ease of use will remain crucial in an era where data privacy and application reliability are paramount. In conclusion, Docker's history, impact, and ongoing evolution are a testament to the transformative power of innovative technology in the software industry. Its ability to address the challenges of the pre-Docker era and streamline software development and deployment has made it a critical tool for developers, operations teams, and businesses worldwide. And so to sum it up, thank you for your time and attention. I hope this presentation has been of good use to you. I hope it perhaps encourages you to research your own on Docker. The best way to learn is to just jump in and start to play with it. And from there, the possibilities are endless with what you can use with this great technology. So thank you for your time. I hope you have a great evening, and we'll see you next time.